So we saw that a conservative force is path independent. And we also had examples of forces which are path dependent. If you have path 2 and path 1. And the work done is path dependent. So that means for each path we would get a different answer. Then we call this force F, we denote it by NC, is called non-conservative. And again, we see that friction is the best example of a non-conservative force. And if we go again for non-conservative work, if we integrate from the initial point to the final point, for instance, on our path 1 of this non-conservative force, so if we integrate this way, and if we reverse the integral, and so we go back from the final point to the initial point on path 2, that these integrals will not be equal to the negative of each other because the quantities are different for the different paths in general, and so this is non-zero. And in fact, that's the property of non-conservative forces, that the work done around the closed path for a non-conservative force is not equal to 0. In general, there may be one specific closed path in which that answer is 0, but in general, it's non-zero.